Hi, hello friends, welcome to the channel. In today's video, we'll be seeing Unit 4 of Mechatronics Programmable Logic Controller. Question number 1. Programmable Logic Controller is a microprocessor based controller that uses a programmable memory to store instructions and to implement functions such as logic, sequencing, timing, counting, and arithmetic operations in order to control machines and process. Option A is given as true and option B is given as false. What this question means is programmable logic controller is a microprocessor based controller. Is a controller. Controller means controls things that uses a programmable memory to store instructions and to implement functions. In order to implement functions, it has some instructions which is in a program format, and it is used to implement functions such as logic, that is and, or, nor, XOR, sequencing. Timing means timing of the operations, and counting, how much time the program started, how much time it taken, how much time elapsed, that all comes in counting. And arithmetic means arithmetic operations, addition, subtraction, multiplication, division, that all comes in arithmetic operation in order to control machines and process. To control the machine and the process, it does logic, sequencing, timing, counting, and arithmetic operations. Some software downloading will be up to 3 hours. Takes, if you are downloading ANSYS at low speed, it takes up to 3 hours. I assume 3 hours. That calculations come in arithmetic and logic calculations, sequencing calculations, which sequence must comes first. That all is done by a programmable logic controller. Program logic controller is a microprocessor based controller. Okay, so I'm going with option number A, true. Question number 2. The main components parts of PLC, programming logic controller, programmable logic controller. What are the main components of PLC? Option number A is given as CPU. Option number B is given as input output unit. Option number C is programming device. Option number D is memory unit. Option number E is given as all the above. The 4, CPU, input output unit, the programming device, memory unit, all are the components, are the main components of PLC. So I'm going with option number E, all the above. Question number 3. The functions of programming device are. What are the functions of programming device? Option number A is given as a programming device is used to enter the required program using ladder logic into the memory of the processor. Option number B, the sequence of operation and ultimate control of the equipment or machinery is specified and determined by ladder program. Option number C says both A and B, and option number D, none of this. Programming device is used to enter a program. You all know that a programming device is used to enter a program. This program is entered by using a ladder logic. Means ladder logic is a logic means way. Ladder means type of a program. Ladder logic into the memory of the processor. You are entering the program using ladder logic in the memory of the processor. This is the job of the memory device. Programming device. Second is sequence of operation and ultimate control of equipment. This ultimate control of an equipment means running of a motor, that all be controlled by this programming device. There will be a small motor in our hard drive. That gives the correct system at sequence, which program must be going, which program must be done. It is coming under mechanical field. Okay, in a computer is coming under computer field, but that motor part running all will be used with mechanisms. That mechanisms is controlled by this programming device. That means ladder. There will be a ladder. Suppose this part has a ladder, and here will be some set of programs, here will be some set of programs, here will be some set of programs, here will be some set of programs. There will be a motor running for 10 seconds. The ladder will be at this place. After 10 seconds it moves to this place, and this program is be executed. First this program will be executed, then this is a ladder, then this program will be executed, then this after some time this program will be executed, after some time this program will be executed. Here the timing, sequence, first which sequence, for how much time the ladder should be in this particular program, how much time this particular program, that comes under timer, then counter, that all work sequence, and the ultimate control of equipment and machinery is done by this ladder program. This is a ladder program. Okay, the programming device is used to enter the required program using ladder logic into the memory of the processor. The sequence of the operation and ultimate control of the equipment or machinery is specified and determined by the ladder program. The sequence of the operation and the ultimate control of the equipment or machinery is specified by this ladder program. And also ladder program is used to enter required program using logic into the memory of the processor. So I'm going to option number C, both A and B. First, the programming device is used to enter required program. What is the primary function of a programming device? Is to enter a program. This program here in PLC is entered using ladder logic. Where it is going? It is going to the memory of the processor. After memory of the processor, when it goes to the memory, then only the defined program can be executed. This programming device says which program to enter first. Okay, sequence. So sequence in operation and ultimate control of the equipment and machinery means if you are saying this particular program, then the left part of if you are controlling a robot, then the left arm will be executed. If this is for left arm, then left arm will be executed. Then if this is for right arm, then right arm will be executed. Then if it's walking, left leg first, right leg first, that all be controlled by this this programming device. Okay, option number C, both A and B. Question number 4, various types of PLC programming devices are. What are the various types of PLC programming devices? Option A, use of handheld programmer. Option number B, terminal with a video displaying unit. Option number C, a personal computer with appropriate software. Option number D, all the above. Where these PLC programming devices are used? It's used in handheld programmer. As handheld machines means the machines which we use by our hands, within our hands, such as phones, remote controls, that all. Okay, video playing, that video games also will be having joystick in our hands, that also controlled by PLCs now. And personal computer means our desktop also we are for hard drive running, disk drive running, will be using this PLC devices. So I'm going with option number D, all the above. Pick the correct statements of RAM. What is the correct statements of RAM? We have been studied from our lower classes what is RAM. Option number A, pick random access memory is used for the user's program and data storage. Option number B, information can be written into or read from the memory. Option number C, normally incorporated in the solid state form contained in an integrated circuit. Option number D, all the above. RAM means random access memory. Random access memory is used for users programmer and data storage. RAM is used for storing a program and what it is users program only. Users program and it is done in a data storage. So it is used for data storage function. Information, option B says information can be written into or read from the memory. After storing of a particular program in the data storage, we can after some time we can read, we can edit that, we can overwrite on it. That can be done in RAM. In ROM we can't write, we can just only read. Option number C, normally incorporated in solid state form contained in an integrated circuit. It is a hard component, that is a hardware component, RAM. It is come along with integrated circuit, okay, or IC chip. So I'm going with option number D, all the above. It is not a software. RAM is not a software. It is along with the hard storage device. It is coming along with our integrated circuit. So I'm going with option number D, all the above. Question number 6. Counters allow a number of occurrences of input signals to count or record the number of times some event occurs. Counters allow a number of occurrences of input signals to count or record the number of times some event occurs. Option number A is given as true and option number B is given as false. What are counters? What are the function of counters? Counters allow number of occurrences of input signals to count. It is going to count the number of occurrences of input signals or record the number of times of an event occurs. If an event occurs, how many times this event is occurring? A particular event is occurring this time, or a total events occurring this time. That all how much numbers, that all be counted by this counter. So I'm going to option number A, true. Question number 7, the various types of counters are, we have generally two types of counters, that is down counters and up counters. Option number A is given as down counter, option number B is given as up counters, option number C is given as both A and B, and option number D is given as none of these. The various types of counters are down counters and up counters, so I'm going to option number C, both A and B. Question number 8, pick the correct statements of cascade counters. There is a particular type, there is a particular counter called cascade counter. We'll see what the use is. Option number A, cascade counters are needed or required to count events that exceeds the maximum number allowed per counter instruction. Generally we have down counters and up counters, but this down counters and generally counters can count till up to a particular number. After there are only, it can count till only 1000 count, means there should be 1000 counts. The counter is of 1000 counts, it can't count above 1000. In such cases, we will be using cascade counters. In using cascade counters, we can count infinite numbers of counts. Option number A is given as cascade counters are needed or required to count the events that exceeds the maximum number allowable per counter instructions. That means if exceeds the maximum count exists, then also you can count by using cascade counters. Option number B, the counters are programmed in series to produce an output in way that output the first counter is programmed to the input of the second counter. How this counting is done means, if there are series of counters, okay, there are series of counters. If each counter can count till 1000, then after, if this counter has this counter A, B, C and D, I'm naming this as A, B and A, B, C, D. If A has counted 1000, then the B counter starts from 1001 till 2000. Then after C, it will count from 2000 to 3000, 2001 to 3000. Then D will be counting from 3001 to 4000. Thus, you can count from down till 4000. If you need 5000, then you can add counters. Okay. In this case, if the output of A is given as input of B, the output of A is 1000, 1000 plus 1 is 1001. From 1001, we are counting from B. Okay, so I'm going with option number C, both A and B. Question number 9, master control is often necessary to provide means of executing sections of the counter logic which, when certain criteria are realized, they include instruction comprising the override instruction. Master control means controls everything. It is often necessary to provide means of executing sections of the control logic when certain criteria are realized. If you are going and suddenly you recognize this part is wrong, then what you will do? Then you will come back and go to another part, or you will omit this. If you are going from here to from Mumbai to Delhi, or from Delhi to Chennai, suddenly you were going by car and you realize that the Google map is wrong, so you take some diversion. You will take a diversion and go by another road. In the way, this master control also takes. Master controller acts. They will be going with a program. Suddenly this program is recognized to be wrong, then it will only recognize, and there is a instruction to override the instruction. This instruction is wrong, A is wrong, just go take to the program to B, loop B, then go to C. That will be, we can override the instructions by using master control. So I'm going with option number A, true. Question number 10, classification of data in manipulation in shift registers include. In shift registers, the classification of data manipulation in shift registers include means, there are two classifications or characterizations or classifications of data manipulation in shift registers. One is data transfer, other one is data comparison. So I'm going with option number C, both A and B. Question number 11, which is the correct statement for jump control? Option number A, jump control means jumping or skipping from an instruction which is not required, which is of lesser importance. Option number A, jump instruction. The jump instruction is an output instruction enabling part of a ladder program to be jumped over. Option number B, with jump instruction, the process scan time can be reduced by jumping over instructions not pertinent to the machine operation, but that means importance, which is not important. Option number C, thereby missing intermediate program and can skip instructions with a production fault occurs. When a production fault occurs. Option number D, all the above. Jump instruction is an output instruction enabling a part of a ladder program to be jumped over. By using a jump instruction, we can jump or skip a program, a line of a program, okay, instruction of a program. Option B, by skipping, if you are skipping, if you are writing an imposition, and if you are skipping, if you are just imagine you are writing some essays or an imposition, there is an 1000 lines, and you are skipping in middle 2 to 3 lines or 5 lines or 10 lines, then what happens? You can finish fast. You can finish fast. That is, the scan time is reduced. That is, we can finish fast. Thereby, missing interprogram can skip instructions when a production fault occurs. If there is no problem, then you can skip the instruction because the instruction is not so much important. So there is no production fault. So I am going with option number D, all the above. If there is a production fault also in this jump or this in system, I'm talking about this in mechatronics. If there is any production fault, if you are executing that function, then the program, then there will be certainly a production fault. That in that conditions also you can skip, you can jump over that instructions. For that also you are using jump control. For all which purpose you are using jump control? You are using a jump control for skipping an instruction. For skipping an instruction, we can gain more scan time. The scan time can be reduced. Okay. For that purpose also. Third means if there is a fault also to jump that from not doing that program, we can jump to skip to next one. If n is the problem 1, we can directly go to n+1 stage. For that purpose also we are using this jump control. So I am going with option number D, all the above. Question number 12, PLC programming methods include. Option number A, structural test. Option number B, ladder diagrams. Option number C, functional block diagrams. Option number D, sequential functional charts. Option number E, that is instruction list. Option number F is all the above. Okay. Yep. And this is E. There are 5 programming methods, PLC programming methods, that is structural test, ladder diagrams, functional block diagrams, sequential function charts, and instruction list. So I am going with option number F, all the above. These 5 are the methods of PLC programming. In structural test means structures. You are writing the test in some structures. That means in some language, program language. Then ladder diagrams also. I told you what is ladder diagram. Functional block diagrams. In a functional block diagrams you have seen. Sequential function charts. Some function charts giving sequence, correct sequence, and instruction list. Okay. Instruction list, writing an instruction. In all these programming methods you are writing, your PLC programming methods can be done. So I am going with option number A, all the above. Thank you guys. Thanks for watching. Hope you like this video. We'll meet in a new video. Thank you guys. Thanks for watching. Once again, bye.